So let's start Chapter 2, Objective 1. It's actually Chapter 2, Section 1, Linear Equations in One Variable. And we're going to look at Objective 1, Solving Linear Equations Using Properties of Equality. So we've got a few definitions we want to go over. So let's define a linear equation in one variable. The key word here is equation. So an equation is always going to have an equal sign. And the literal, the actual real definition is an equation is a mathematical statement that says two mathematical expressions are the same or have the same value. But in our case, a linear equation in one variable is going to have the form ax plus b is equal to c, where a, b, and c are real numbers. And in particular, I guess the most important part about this, because it should come as no surprise that a, b, and c are real numbers, a is not equal to 0. If a is equal to 0, then the first term, 0 times x, is 0, and the variable term vanishes, so we can't have that. And this is a linear equation in the variable x. We could also have a t plus b is equal to c, and that would be a linear equation in the variable t. But for the most part, I mean, x is just a dummy variable. You could choose any letter. For the most part, we're going to use x as our variable. So a specific example is 7x minus 3 is equal to 18. In this case, a is equal to 7, b is equal to minus 3, and c is equal to 18. Now, you're not ever going to be asked to identify the a's and the b's and the c's, but you should be able to look at an equation and say, oh, that's a linear equation, and it's in the variable x. 8x is equal to 0 is also a linear equation in one variable. It can be written as 8x plus 0 is equal to 0, and that has the form of ax plus b is equal to c, in which case b is equal to 0 and c is equal to 0. But that's okay, because our only restriction is that a is not equal to 0. So let's go on to the next concept. The solution set of a linear equation. So the solution set of a linear equation is, let's first define what a solution to a linear equation is. I'm just going to write LE for linear equation because I'm being lazy. That is a value of the variable. So remember, the variable unknowns, they're the same thing, which makes the equation true. So just up above, I gave you the example, 7x minus 3 is equal to 18. Well, let's let x be equal to 2 and see if that's a solution. Well, what I do is I replace x by the value of 2, and I evaluate this side of the equation. 7 times 2 is equal to 14, and 14 minus 3 is equal to 11. And we wanted it to be equal to 18. So x equals 2 is not a solution to this particular equation. Well, let's try another value. Let's try x equals 2, 3. Well, then we have 7 times 3 minus 3. Well, that's equal, 7 times 3 is 21, and 21 minus 3 is indeed 18. So x equals to 3 is a solution. So the solution set of a linear equation, the solution set is the set of all numbers, and of course when I say numbers I mean real numbers. You'll actually see some numbers which aren't real numbers toward the end of the class, which make a specific equation true. So going back up to this particular equation, 7x minus 3 is equal to 18, as it turns out, our only solution is 3. So the solution set is 3. And remember, when we create a set, the elements are placed within brackets or curly braces, and they're separated by commas if there's more than one element. As it turns out, the solution set for a linear equation, there's 3 possibilities. The solution set will either, this is only for linear equations, very important. What I'm telling you only holds for linear equations. Will have, there's 3 options on our menu. 1, exactly 1 solution or 1 element in the set. The example I just gave you. B, every real number is a solution. Or C, no number at all is a solution. In that case, we say that the solution set is empty. And equivalent equations. It's an important concept, but just something to keep in the back of your mind. Equivalent equations are equations that have, can you guess, the exact same solution set. And what our job is going to be is to transform linear equations until we get something like the following. X is equal to b, where x is our variable, b is an actual number like x is equal to 3. In this case, there is only one solution to the equation, and that's the number b. The other possibility is x, for example, I'm going to give you an example right here. For the first, we just had an example, x is equal to 3. Just one solution. This is the solution set. The next possibility is we have a is equal to b, where a and b are not the same number. So there are no variables. A is a known number and b is a number, such as 0 is equal to 7. In this case, the solution set is empty. There are no solutions. You all have 2 options. When you're writing things, for me, you can denote the empty set as just 2 curly braces with nothing in them. But the more standard way is to draw a 0 with the slash through it. And I'm pretty sure that's the symbol that the book uses, and that's the symbol that my math lab will want you to use. And the final case is something just like this. X is equal to x, when x is our actual variable. Or something like 5 is equal to 5. In that case, the solution set is the set of all numbers. One way to denote that is to write x. This dash is read such that x is a real number. We have other more convenient ways to write that, but that's what the book uses, and I'll stick with what the book uses. So remember, this is a set. What's in the set? Numbers. What are those numbers like? Any real number is in there. So that's the case when all numbers work. And we'll look at those. First thing we're going to do is to use and introduce some properties that allow us to solve our linear equations. So the first one is going to be the addition property of equality. And if you've done the book reading, and I do please encourage you to read the book material before you actually sit down at a lecture, if you can stomach it. My view is when you get up into the real world and you start looking for a job, you might be given an instruction manual that is, oh my gosh. By reading and trying to figure out math, you've already got a difficult instruction manual, and when you get something new, you say, oh, math was harder than that. At any rate, the addition property of equality, I denote this a little bit different. So if x is equal to b, then x plus c equals b plus c is an equivalent equation. So let's unpack this. So clearly x is equal to b is an equation, right? There's the very important equal sign. Without an equal sign, it's no equation, there is no solving. This states that x is equal to b. So for any real number c, x plus c will also be equal to b plus c. So I just added c to both sides. You can kind of think of it this way. I'm not a very good illustrator. If you have a balanced scale, and our scale has, say, 3, whatever you want to call these, marbles or golf balls or whatever. So if it's balanced. So in order, balance meaning equality. So if I add another ball to one side to keep the balance, I have to add it to the other. For example, an actual example, let's say x is equal to 3. If that is true, then x plus 2 is equal to 3 plus 2. I added 2 to both sides, and clearly the solution to this equation is obvious. X is equal to 3. So let's plug in 3 down here. Look, I get 5 is equal to 5. So good job. So that's the addition property of equality. And remember, when we use in mathematics the word addition, we also include the addition of negative numbers, which is known as subtraction. So just a reminder, a minus b is the same as a plus the additive inverse of b. So we're going to be using the addition property of equality and the multiplication property of equality as well. So the multiplication property of equality, slightly different. Suppose, again, that x is equal to b. Now, if c is not equal to 0, and of course it's a real number not equal to 0, cx equals to cb, that's a b there, that this equation and this equation are equivalent. So basically what that tells you is, if I have an equality, as long as I multiply the entirety of both sides by the same non-zero number, I have equivalent equations. So let's look at Objective 2, solving linear equations that can be simplified by combining like terms. So let's solve using the addition and the multiplication principles. So let's look at 1a. We're going to do these a few different ways here at first. I have 2x plus 5, and that's equal to 9. Now the trick is to isolate the variable terms, and my variable is my x. This is a linear equation in the variable x, and the 2 is called the coefficient to the variable term, or it's called the coefficient also to the x term. And the 5 and the 9 are called constants. So what we want is to get the variable terms on one side and constants on the other. So I want this 5 to go away. So if I use the addition principle, I can subtract 5 from both sides. I have to subtract 5 from both sides, otherwise I break the equality. So 2x plus 5 minus 5 is 2x plus 0, and you don't have to write 2x plus 0. I'm just doing this in excruciatingly small steps, just so you can see everything. And this is 9 minus 5. So now let's simplify both sides. 2x plus 0 is just 2x. Why? Because 0 is the additive identity. 9 minus 5 is 4. So now I know how many 2x's are. I want to know how many 1x is. So here I need to use the multiplication principle. I need to multiply both sides so that I get a 1x instead of a 4x. So what do I multiply 2 by to get 1? Well, I multiply it by its reciprocal, right? So I'm going to multiply both sides by 1/2. Remember, I have to do it to both sides. So 1/2 times 2 is 1, so that leaves me 1x. And I don't write 1x, I just write x. And 4 times 1/2 is the same as 4 divided by 2, so that's equal to 2. So that's one way to do it. In general, that is not going to be the way I do it. There's an easy theorem, or something that we can easily prove, by the addition principle of equality. If I want to move a term, like the plus 5 term, and I want to move it to the other side, I can do so, but I have to pay a price for doing so. The price is it changes its sign. Since that's a plus, it has to change to a minus. And I'm already back to where I was before. 2x is equal to 4. And here, one more variation. If I want, instead of multiplying both sides by the reciprocal of the coefficient, since the coefficient is just a whole number, I can just divide both sides by 2. 2 divided by 2 is 1. 1x is 4 divided by 2, which is 2. And one last method. I used this a lot when I was maybe a sophomore in high school, is the cross multiplication method. Again, we're using just the exact same problem. And 9x plus 5 is equal to 9. Use whatever method you want to, not 9x. That's a 2. 2x plus 5 is equal to 9. Use whatever method you want to get to the step 2x is equal to 4. You can just move the 5 over, or you can subtract formally minus 5 from both sides. Now, cross multiplication requires you to turn these into fractions. But when you turn them into fractions, you can't change the value because you've changed the problem. The easiest way to do that is just put them over 1. Anything divided by 1 is the same thing as anything multiplied by 1. They're the exact same thing. And now, at this case, what I do is I go from the bottom. So this is my x term side over here. This is my x term. So I start there. I multiply the 1 times the 4, and then the 2 times the 1. And that's going to leave me an x all by itself. 1 times 4 is 4. 2 times 1 is 2. So that gives me x is equal to 2. And we have the exact same answer all three ways. Any of these three ways, or any combination of those three ways, are always fine. And if you have some other way that works, you can use that as well. The way I will work things is almost always going to be that way. So let's do another problem. Let's do the second one, 1b. So we have 0.6 is equal to 2 minus 3.5. So I'm going to do two things at once. That's a C. So this is a linear equation in the variable C. C is our unknown. 3.5 is minus 3.5. That's the coefficient of my C. I myself personally like my coefficients to be positive. So I'm going to move this entire term to the other side. So I can do that. The price I pay is the price I wanted to pay. It becomes positive. My 0.06 is my 0.6 is still there. And remember, when we don't have anything written in front of it, it's considered positive. And not considered positive, but it's a plus. In this case, it is positive because it's an actual number. And here, the 2 is still over here. But again, my whole goal is I want to isolate my 3.5c because my c is my unknown. So I'm going to take this term now and move it over here. So that leaves my 3.5c by itself. That's what I wanted. I wanted to isolate that term. And this is 2, and the price I have to pay is it changes its sign. So it becomes minus 0.6. So we have to simplify this side over here. So 2.0 minus 0.6. Borrow. 10 minus 6 is 4. 1 minus 0. That gives me 1.4. So I have 3.5c is equal to 1.4. So here I have 3.5c, and I want to have and know what 1c is. So what I'm going to do is I'm just going to divide both sides by 3.5. It works even if they're decimals. So 3.5 divided by 3.5 is 1, so that gives me 1c. And over here I get 1.4 over 3.5. But this is not an answer I like, and it's not an answer that my math lab is going to like. We want to change that. So how do I simplify 1.4 over 3.5? I don't want you to, this is when you're dying to get out your calculator. Don't do it. I can't change its value, but what I can do is I can multiply it by 1. If I multiply this by 1, then I have not changed its value. But I'm going to multiply it in a special form of 1. 10 divided by 10 is just 1. So when I multiply 1.4 by 10, I just move the decimal place over and I get 14. When I multiply 3.5 times 10, I move the decimal place over and I get 35. Now you should realize that 14 is equal to 7 times 2 and 35 is equal to 7 times 5. And that is equal to 7 divided by 7, and I wrote 2, not 7. 7 divided by 7 times 2/5. But 7 divided by 7 is just 1. So my final, most simplified answer is 2/5. So let's do another problem. As a matter of fact, I'm going to suggest that you try to work problem number C on your own and see if you get my answers. As a matter of fact, I'm going to highly suggest that method when you're watching these lectures, and even or if you're watching the Pearson lectures. Of course you won't hear what I'm saying if you're watching those, to do it that way. When you're given a problem, pause the video, try to work it on your own, fast forward through it if you want, and see if you got the right answer. If you didn't get the right answer, in this case, these examples are literally coming pretty much straight from the book, exactly as they are. So this is a linear equation in the variable t. So again, it's my preference always, when my variable term has a negative coefficient, I want to move it to the other side. So that gives me 2.5t plus 2.5 is equal to 3. Now I'm going to move my 2.5 term to the other side. Why? Because I want to isolate my variable term. So my variable term stays where it's at, and this becomes 3. When I move it over, the plus 2.5 becomes a minus 2.5. So I have 2.5t in 3 minus 2.5. I hope you can see that is equal to 0.5. And now again, I want to know what 1t is, so I'm going to divide both sides by 2.5. So my answer, my first answer, and it is numerically correct, t is equal to 0.5 over 2.5. But my math lab does not like that answer, nor do I. I want it to be a real fraction, where the numerator and the denominator are both whole numbers. So I'm going to use the trick again and multiply both sides by 1, disguised in the form of 10 divided by 10. And 0.5 times 10 is equal to 5. I just moved the decimal place over 1 to the right, the same number of zeros as 10 have, and then I move 2.5, the decimal place, 1 to the right. So t is equal to 5 divided by 25, and that simplifies as 1/5. And that's our answer for that question. I think literally, if you look in my math lab, not in my math lab, but if you actually look in the answers in the book, they allow this as an answer. They are numerically equivalent. This is a much better path to go, I think, for reasons which will become abundantly clear later on as we get into more complicated things. So now let's go ahead and do 1D. So 1D is minus 4x minus 1 plus 5x is equal to 9x plus 3 minus 7x. And here we're going to do something called collect like terms. So in this case, we have our constant terms, which is minus 1 and 3, and our variable terms is minus 4x, 5x, 9x, and minus 7x. So I'm going to collect like terms by writing the like terms next to each other first. So the variable terms on the left-hand side I write next to each other, but I can't forget the minus 1. And over here I'm going to write the variable terms next to each other. And I can't forget the plus 3. So now, after we've collected like terms, we're going to simplify. So I've done that, and now I'm going to simplify. So minus 4x plus 5x is the same as 5x minus 4x. So that leaves me 1x, and I have the minus 1. I didn't do anything to that. In other words, all I did is I simplified these two by adding. Now I'm going to simplify those two by adding. 9x minus 7x is 2x plus 3. Sorry, I did not get the exact same color, but that's okay. Now we're ready to get all of the variable terms on one side. I like my variable terms to be positive if at all possible, so I'm going to move the x term over here. The minus 1 stays, so it goes going to give me 2x. Since x that's understood to be a plus there, it becomes a minus, and the plus 3 has to be brought down. Now I'm going to simplify by combining like terms. 2x minus x is x plus 3. And finally, I'm going to move my constant term here to this side. So when I do, it changes sign. So I have minus 1 minus 3 is equal to x. How nice that I already have 1x. And minus 1 minus 3 is minus 4. And that's equal to x. Now I'm doing all of these in several steps. The only thing I would tell you when you're doing it, because you don't want to take that long, is you always want to collect like terms. But once you get to this step right here, you can move everything all at once. Here I move the x over here. I could at the same step move the 3 over to the other side. Okay, here we have a new one. We're going to have to use another property of the real numbers that you learned in or you reviewed in our Chapter 1 material. So this is, I believe, 1e. I think we're on 1. It doesn't really matter. So we have 2 times x minus 3 is equal to 5x minus 9. So the first thing we have to do is we have to simplify this side. And we simplify this side by using the distributive law. So I multiply 2 times x. I distribute the 2. So 2 times x gives me 2x. 2 times minus 3 gives me minus 6. And that's going to be equal to 5x minus 9. So here I'm going to do both at once. I'm going to move my 2x term over here, and it's going to become minus 2x. Now I'm going to move my 9 term over here. So my equal sign, my 5x is staying. When I move my 2x over, it changes sign and becomes minus 2x. My minus 6 stayed, but the minus 9 moves over. So the price it pays is the minus is dropped. It changes its sign. Oh, that's much better. 9 minus 6 is 3. And 5x minus 2x is 3x. So now all I have to do is divide both sides by the coefficient of the x term, which is 3. It's the same as multiplying both sides by 1/3. So 3 divided by 3 is 1, and 3 divided by 3 is 1, and 1 times x is x. So in this case, our answer is x is equal to 1. So now we're going to go to objective 3. Solving linear equations containing fractions or decimals. And this is a really important part. We're going to be doing a lot of this, so definitely put on your thinking caps. You'll want to review some things probably, because we're going to have to learn how to find the least common denominator, also known as the least common multiple. But after that, it's pretty simple. So here's the trick. When you see problems containing fractions or decimals, it's really not that bad. And we'll have a lot of practice doing this. So let's do this particular problem. So this is problem A. So I have y divided by 3 minus, whoops, it's a y, and that's equal to 1/6. So this is a linear equation in the variable y. So what do? Who wants to deal with this? Well, we note our denominators. Our denominators are 3, 4, and 6. So we have to find the least common denominator of 3, 4, and 6. In other words, I'm looking for the smallest possible number that is evenly divisible by 3 and 4 and 6. And that number is 12. 12 divided by 3 is 4, whole number. 12 divided by 4 is 3, whole number. 12 divided by 6 is 2, another whole number. That's the smallest number that has that property. So the first thing you do is you find the LCD of all of the denominators. And then what comes to rescue us is the multiplication property. I multiply the entirety of both sides by that LCD. This process is also known, this entire process is known as clearing denominators. And of course, I was good at doing fractions, denominators. And I would just plow through it and add the fractions, subtract the fractions, and do whatever. And it wasn't until I was preparing to go to grad school that my teacher says, Kent, you got to stop doing that. You need to clear the denominators. It'll be so much easier. And of course, I respected it a lot and listened to it. Oh, it was so much easier. So I'm going to rather insist that you do it. So notice, I have an equivalent equation. I have an equation, and I've multiplied the entirety of the left-hand side by 12 and all of the right-hand side by 12 too. You must put these in parentheses. One of the most common mistakes at this point is you don't multiply the entire left-hand side by 12. You only multiply the first term, and that breaks the equality, and we can't break the equality. So here we go. I'm going to use the distributive property. So let me get a little bit more room here. I'm going to do 12 times each term. So 12 times y divided by 3 is the same as 12 divided by 3 times y. But 12 divided by 3 is 4, and 4 times y is 4y. 12 divided by 4 is 3. And 3 times minus y is minus 3y. It's already looking better, isn't it? 1/6 times 12 is the same as 12 divided by 6, which is 2 times 1. So that becomes 2. So 4y minus 3y leaves me just 1y, and y is equal to 2. Isn't it much better to deal with something like this than try to add, or in this case subtract, y fourths from y thirds? If you did it properly, you'd still get y is equal to 2, but the process of clearing denominators is what takes this into what seemingly seems a nasty problem and just something that really turned out to be quite easy. So let's look at the next one. So this one's not so bad because it's really easy to find the least common denominator here. But this has a very important step, otherwise I would skip it. But this actually contains a potential error that is the most common error in all of college algebra. So let's do x plus 5 divided by 2 plus 1/2 is equal to 2x minus x minus 3 over 8. So the first thing I want you to notice, this is a minus sign right here, and this numerator is not a single element. It's a subtraction. It wouldn't matter if it was x plus 3. As soon as you see that, you need to put parentheses around it. When you put parentheses around an expression, you don't change it, but by doing that, you're going to prevent yourself from an error. The error comes from this negation right here. So that's the first thing you notice. Here I'm subtracting a fraction whose numerator is a sum or a difference. So that's the first thing we do. The second thing we do is we find the LCD of the denominators, and that's 2 and 8. And whenever you have the LCD of two numbers, if the smaller of the numbers divide the larger, then the answer is always the larger. So what do? We wrap the entirety of both sides in parentheses and multiply by our LCD. I'm going to put my 8 here. Oh, maybe I could squeeze in if you really care. I'll squeeze in another 8 here. Of course, I'm going to have to write my equal sign in there. We can't forget that. So now let's start. We're going to use the distributive property. So 8 times x plus 5 divided by 2 is the same as 8 divided by 2 times x plus 5. And I'll be honest with you, it's probably a good idea, even though there's not a minus here, whenever you have a numerator that is a sum or a difference, is just go ahead and put parentheses there. So 8 times x plus 5 divided by 2 is the same as 8 divided by 2, which is 4, times x plus 5. I hope I'm not driving you all crazy by changing the colors. Oh well. 8 divided by 8. Now I'm going to use the distributive property again and multiply 8 times this term. So 8 times 1/2 is the same as 8 divided by 2, which is 4 times 1. So that's plus 4. So again, using the distributive property, 8 times 2x is just 8 times 2, which is 16, times x. And 8 times minus x minus 3 over 8 is the same as 8 divided by 8, which is 1, times minus x minus 3. It's really important you have those parentheses there. So we got to do another step in our simplification. We're going to use distribution again. 4 times x is 4x. 4 times 5 is 20. I can't forget my 4. And this is 16x minus x minus 3. That's the same as minus 1 times x minus 3. So minus 1 times x is minus x. Minus 1 times minus 3 is plus 3. And that's exactly the error you will get if you don't put this in parentheses. You'll have minus x minus 3, guaranteed. At any rate, you've been told you have to practice. Let's collect like terms and simplify. So the 4x, the only two like terms on the left-hand side is the 20 and the 4, so that's plus the 24. And 16 plus 3 is 19 minus x. So I'm going to bring the minus x over to join the x over here. So the minus x becomes a plus x. And then I'm going to move the plus 24 on the other side. It has to change signs. So 4x plus x is, did I miss a 15x? Oh, sorry. If you're at home, you're screaming at me. You'll get used to it though. I made a mistake. Notice right here, when I copied it down, I forgot to write down a 16x. So let's just go back to right there and start all over. That's the reason I do these problems beforehand, is to catch things like this. When you talk and write, it's so easy to drop something that's important. So this is 4 times x. We still get 4x. 4 times 5 is plus 20. And I have a plus 4. And that's equal to 16x. I forgot to write down my x. And this was minus x plus 3. So now when it comes to the combining of like terms, I have something to do on both sides. So my 4x, that's my only variable term on the left-hand side. My 20 and 4, I can combine those to get 24. 16x minus x is 15x plus 3. So now what I'm going to do is I'm going to move the 4x to the other side. And it becomes minus 4x. Now I'm going to move the plus 3 to the other side to join my 24, and it becomes minus 3. So 24 minus 3 is 21, is equal to 11x. And now all I'm going to do is divide both sides by the coefficient on the x term. And don't forget to write your final answer. Your final answer is 21 over 11 is equal to x. So don't leave your answer in this form. Write it in this form. And the last example we want to do is how to deal with decimals. That's part of the deal. And again, this is the reason we don't want you to use a calculator. Whoops, no. If you were using a calculator, you just start hunking this out in the calculator, and you're going to be missing a very important property. So the first thing is, this is a variable. This is a linear equation in the variable x. 0.3x plus 0.1 is equal to 0.27x minus 0.02. Wouldn't it be nice if I could get rid of those decimals? But we can. And here's the thing. Let's look at this term right here, 0.27x. Let's just look at 0.27. What happens if I multiply it by 10? Well, that means I just move the decimal place over. I get 2.7. Oh, well, it's still a decimal. I want to completely get rid of the decimal. So if I multiply it by 100, I move the decimal over 2 places and I get 27. So if I multiply both sides by 100, the 0.27 becomes 27. The decimal disappears. Will it make the decimal disappear on this term? Well, let's ignore the x for right now. Multiply that by 100. What do? I move the decimal 1 place, 2 place over, so I get 30. So that's the trick. I find the term and I look at the total number of significant digits past the decimal. This only has 1, this only has 1, this has 2. So I multiply it by 1 with 2 zeros, 100. And I'm going to multiply both sides by 100. So again, I enclose everything in parentheses. And I'm just going to multiply each side. So I'm going to use the distributive property again. 100 times 0.03x gives me 30x. I just move that decimal place on the 0.3 over 2. 100 times 0.1 gives me 10. 100 times 0.27x gives me 27x. And 100 times minus 0.002 gives me minus 2. Now this is a much easier problem to solve. So again, I'm going to move the 27x over here to get 30x minus 27x. And that means I have to move the 10 over there, and it becomes minus 10 minus 2. And 30x minus 27x is 3x. And minus 10 minus 2 is minus 12. So now I'm going to go ahead and divide both sides by 3. And I'm going to get x is equal to minus 12 thirds, which you can write as this way. But 12 thirds can be simplified to minus 4. So x is equal to minus 4. Okay, now let's go ahead and we're going to do recognizing identities and equations with no solutions. That's going to be our last objective. Get some more digital white space here. So remember, there's 3 possibilities. We have, when we do the solution, or when we're working out and discovering the solution set for linear equations, we have 3 possibilities. The first possibility is we have x is equal to some number b. X is our variable. That means exactly one solution. And what is the solution? Well, it tells you the solution to x is equal to b. Our other possibility is a is equal to b, where a and b are not the same, like 7 is equal to 3. Well, that's impossible. In this case, we have no solution. In other words, the solution set is the empty set. Up here, the solution set would just contain b. In the final, there's two possibilities. We have x is equal to x. They're identical. So the solution set is all real numbers. Or we have something like 7 is equal to 7. Again, the solution set is every real number. The first situation, the equation is called contingent. It has exactly one solution. In the second situation, when there is no solution, it's called a contradiction. And in the third situation here, where every number works as a solution, that's called an identity. Really, of the three, the contingent is the hard one. X is equal to x. X is always identical with itself. 7 is identical with itself. Identity. If I say 7 is equal to 3, you just contradicted yourself. Contradiction. Contingent, some solutions work, others don't. So going up, let's see which one of these, I guess we can just call this 4a. I don't know what the numbering is. So let's solve 3x plus 5 is equal to 3 times x plus 2. So I'm not going to do anything to the left-hand side, and I'm going to use distribution over here. 3 times x gives me 3x, and 3 times 2 gives me 6. So that's 3x plus 6. So now I'm going to subtract. I'm going to take the 3x and move it over here. So that gives me 3x minus 3x, because when I move it over it has to change sign. And now I'm going to move the plus 5 over, and that's going to give me minus 5. So 3x minus 3x is 0, because minus 3x is the additive inverse of 3x. And 6 minus 5 is 1. So I get a solution where I'm saying 0 is equal to 1. That's impossible. So this is called a contradiction. That's the type of equation it is. And there is no solution. No number works as a solution. And the solution set is the empty set. Now let's do number 4. Let's do number B. I'm going to change that. I want to change the numbers there. I don't know if I had a typo in the original, or this is exactly what is given us in the textbook, but I don't like it, so I'm going to change it to x plus 6 instead of x plus 5, x plus 6. So let's go ahead and solve that. I'm not going to do anything to the left-hand side. I'm going to use distribution over here. 4 times x is 4x. 4 times plus 6 is plus 24. So again, what are we going to get? I changed it to the wrong thing, people. That's okay. What are we going to get? I'm going to move the 4x to the other side. 4x minus 4x. And then the minus 3 is going to come over and become plus 3. And we're going to get another contradiction. 4x minus 4x is 0 is equal to 27. Another contradiction. Sorry about that, people. Let's actually change it to what I wanted to change it to. 2 examples. It doesn't hurt to see a different this is B version 3, and I only meant for there to be 2 versions. So this is the literal version I wanted to do. 4x minus 6 is equal to 2 times 2x minus 3. Again, I'm not going to do anything on this side. And I'm going to use distribution. 2 times 2x is 4x. And 2 times minus 6 is minus 6. So I'm going to go ahead and collect like terms. Well, there are no like terms on either side, so I'm going to isolate out the variable terms. I'm going to move the 4x here over. It becomes minus 4x. I'm going to leave my minus 6 there, but my minus 6 over here becomes plus 6. 4x minus 4x is 0, and 6 minus 6 is 0. Oh, okay. Those two are identical. This is an identity. That means every real number is a solution. So any real number you plug in for x is going to work. And that is denoted in set form as x. This little bar right here is read such that x is a real number. That's a really awkward way to write that. Mathematicians actually have a better way to write the set of all real numbers. We let a set be denoted by an actual letter, and the letter looks like that, and it's R for the set of all real numbers. Is that everything? We have one less more to do. I'm not going to do it. I want you to try to do it on your own. And it's number C. 5x minus 2 is equal to 3 plus 5x minus 1. And the answer that you should get when you're done is that number C is also an identity, which means that every real number works.